Hi guys, recently I noticed that one of my inverters in the Powerwall did not work. After investigating the problem, I just found out that its DC side circuit breaker was not working correctly, so it actually malfunctioned. This is a DIN rail dual pole amp. So DC 50 amps, the inverter which was connected usually pulled around 30 to 35 amps maximum. So there was no overload condition, no short circuit or anything. The inverter is still running fine with a new circuit breaker. Other than a manufacturing defect, I cannot imagine what could have happened here. So what I want to know today is, I want to take a look inside and let's try to find out where this breaker failed. So these kind of dual pole breakers are actually nothing else than two single pole which are connected together. So we will have to remove 4 rivets here, drill them out a little bit here, and then it should be actually fairly easy to remove 1/2 of this. Can we see on the breaker? You see I marked this one, the right side, to be defect. And when I took this breaker off, I hope you can see that somehow, we have the terminals here on the up. This was the DC in, and this one, this side, you can see a red spot here. This spot here is coming from molded plastic. So this was the ferrule which was installed on the cable, which was connected here. So this part actually became quite hot, and so it melted plastic there. And when I now try to move the handle, then you can maybe see that this terminal here, the left one, which is still working, is moving, but this one is completely staying still. So somewhere here inside this part is a mechanical disconnect, and yeah, we are just going to find out what it really is. But just to show you, I have here a multimeter. If I check for continuity, now the breaker is off, we don't have continuity of course. I turn it on, this side perfectly normal and the other side is still open. Okay, let's drill out the rivets. This is just brass, so it should be quite soft. Number 1 is gone. Number 2. Three. And 4. So I want to open this very carefully, of course, because I don't want anything flying out, maybe some spring or something. So I want that we can see this as it should be. Yeah, so easily to remove this upper top, but of course let's just make sure that everything stays on the lower part. So this last rivet still holding a bit. Okay, so it should come off now. Okay, somehow it's connected. All right, so here there's still a part, but it's just looks like it's melted a little bit on the plastic, just sticking on the other half. Okay, and it's off. Right, so very nice. We have a fully assembled breaker here and its other half. Let's take a look inside. Yeah, so this is how these breakers look inside. So this is the upper terminal here, this one the lower. We have the contact here, which is moving when you close the handle. Then the current is going over this braided copper here, over this solenoid. So you see it's just 3 full windings around the magnetic core, I guess. And then on the other side, again, some braided copper and going to the other terminal. So there is here no problem with these connections. Everything is still connected well. Here on the other side you see this box here. This is the arc absorber. Because when we have DC current flowing, different to AC, DC is always present. So when you want to disconnect a DC circuit which is under power, the contact will be pulled away here, but an arc will actually be generated and it will maintain a current if this arc is not somehow stopped. And in this case, the arc will be pulled up here, this metal here, and pulled into this box. And the box is not doing anything else than cooling the arc, and then it will disconnect and extinguish it. So nothing wrong with this, but still something must be the issue here, and I already think I know it, because I think something happened here in this plastic mechanical part. You see, usually when you move the handle, this lever should actually be latched here somehow and pulled up from this side, so that it can be pulled here down against the contact. But somehow this is not happening. So after taking the contact out of the case, we can actually see the point of failure. You see this plastic here, which is holding the metal parts, is completely black and actually also deformed. So all this contact is not straight here anymore. So there was a heat event. So maybe because there was no good contact here, heat was produced and this got very hot here, this assembly, and it melted the plastic. And once the plastic melted, all the alignment was of course gone, and finally, you know, all these plastic arms did not fit together anymore, and this mechanism was completely out of line, not working correctly anymore, and that was it. Yeah, as you can see, at the end these are mechanical devices, and if something is not correctly aligned or not correctly stick together, these sort of devices, they are very cheap. They cost somewhere around $3, produced on fully automatic manufacturing lines, I guess. So sometimes something can go wrong, I guess. But otherwise, interesting to see how something like this looks inside. Maybe we have learned something today. Anyways, thank you for watching. Please like, comment and subscribe to the channel, and I see you next time.